Hello guys, welcome to my new channel. In this video, I'm going to introduce you to a brief on the geographic and hydrological setting of the Darfur region of Sudan. The region is located in the northwestern part of Sudan. It is enclosed between Chad to the west, Egypt to the northeast, and Libya in the north, with a total area of about 490,000 square kilometers. The region is a sandy desert, and rain scarcely falls throughout the year. About 80% of the inhabitants of Sudan depend on groundwater for their livelihood almost all year round. The region consists of 5 parts: the northern Darfur, western Darfur, south Darfur, eastern Darfur, and central Darfur. The main lithology varies from sandstone in the lowlands to hard rock comprising igneous and metamorphic rock in the mountainous areas. The Darfur region is transected by large numbers of geological fractures. Their orientations were found to be in the northeast, northwest and west-northwest directions. These features serve as channels for groundwater reservoir and groundwater movement horizontally and vertically of the host rocks. Groundwater in Darfur plays an important role in providing fresh water for drinking and human activities such as irrigation and industry. This importance increases in water-poor countries in arid and semi-arid regions where rain rarely falls throughout the year. Groundwater tables lie at a depth of 10 to 1000 m. The aquifer thickness varies between 250 and 550 m. Currently, groundwater can significantly affect urban and reclamation development. However, during the late Quaternary, the region was flooded as indicated by lacustrine deposits and paleocarbonate deposits, dried extinct drainage patterns, flora, and signs of prehistoric human occupation. Other geomorphic features such as alluvial fans, buried pediment, old stream channels, and deep-seated interconnected fractures are indicators of subsurface water accumulation. These features are natural recharge sites due to their high permeability and water-holding capacity and can be used in exploring groundwater. Hydrologically, the study area comprises 3 groundwater aquifers: older granite, Nawa series, and Nubian sandstone of the lower Mesozoic. In fact, the geological structure displacements appear to control the divides between drainage basins and drainage network patterns, as indicated by the parallel and longitudinal wadis and the trends of topographical depressions or oases. These depressions and oases are the unnamed depression Al-Natron, Nokila, Hamra, Oyo, Hussein, and Wadi Fesh. Such geological structures create variation in groundwater table and thickness in the Paleozoic, Mesozoic Nubian aquifer, which is estimated to have a reservoir capacity of 75,000 cubic kilometers. For example, the groundwater table in Atrun Oasis ranges between 3 and 6 m, and between 1 and 5 m in the Nokila Oasis. The estimated area of this lake to be 5 times 10 square kilometers, with a water depth of about 3 to 4 m. 5 tributaries drain the northwestern part of Sudan. The Uweinat tributaries drain from the Libyan and Egyptian borders to terminate at the Wadi Fesh, Hamra, and Oyo depressions with 174 kilometers in length. The Endi tributaries drain from the Endi and Mara mountains and terminate at the unnamed depression with 286 kilometers in length. The Erdima tributaries, west, drain from the Erdima mountain in Chad and terminate at the unnamed depression, with 175 kilometers in length. The Mara tributaries drain from Mara mountain and terminate at Wadi Hawar 418 kilometers in length. The Mara tributaries drain from Mara mountain and terminate at Buggar depression in the southeast with 350 kilometers in length. Other tributaries drain from the eastern flank of the northern Darfur paleolake and terminate at the Al-Natron, Nokila, and Hamra depressions. These features are disconnected and dendritic in shape, about 71 kilometers in length, and were well developed in the late Quaternary, a period of high fluvial activity, intensive precipitation, surface runoff, and a long-standing process that was completed during wet phases. The unnamed depression, which occupies an area of 2,000 square kilometers, may have received most of its rainwater during the late Quaternary wet phases when compared with the Nokila, Hamra, and Al-Natron depressions. This is because it is drained by northeast longitudinal paleo-drainage networks. These features reflect flat to gentle slopes for terrain and a high rate of rainwater infiltration and thus groundwater accumulation, while dendritic paleo-drainage networks reflect steep slopes for terrain and a low rate of rainwater precipitation. Finally, don't forget to subscribe to the channel. Please do give the video a like, because that tells me you find this video is useful.